Hello students, let us continue with the chemical properties of group 16 elements. The third property is reactivity with the hydrogen. So how do these group 16 elements react with the hydrogen? Actually this form hydrides of the type EH2 or H2E, where E represents group 16 elements. So EH2 or H2E. So that is a general formula of hydrides. So let us write the hydrides of group 16 elements. H2E we can write in the form of H2E, that is H2O, H2S, H2SC, H2TE, H2PO. So these are the hydrides of group 16 elements. So in this case, the hydrides are actually acidic in nature. So there is a question. Group 16 hydrides are acidic in nature. Why? So all these hydrides are acidic in nature since they are forming H plus ions. They are forming H plus ions. You know H2O forms H plus plus OH minus. H2S forms H plus plus HS minus, etc. So H plus ions are formed in these cases. So these hydrides are acidic in nature. So the acidity is due to, or the acidic nature of this hydrides. The acidic nature of hydrides is due to the formation of H plus ions. So group 16 hydrides are acidic in nature. Now let us see the next property, that is acidity of these hydrides. So which is more acidic or which is less acidic? So let us compare the acidity of these hydrides. So there is a question, that is which is acidic, H2S or H2O? So among hydrides we need to find out which is more acidic. So if it is H2S and H2O, we need to find out the answer. So the answer is actually H2S is more acidic than H2O. So let us find out the answer. So in the case of group 16 elements, when we are coming down the group, the size increases. So we can say the bond length will increases down the group. So we can draw like this. The bond length increases down the group. So the bond length increases down the group. Bond length increases down the group. So when bond length increases, bond strength decreases. So when bond length increases, bond strength decreases. That means when the longer is the bond, weaker will be the bond strength. So we can easily break these bonds when we are coming down the group. So the bond dissociation enthalpy, we can say bond dissociation enthalpy will decreases down the group. So bond dissociation enthalpy, that means the amount of energy required to break these bonds. Since the bonds are weak, it is very easy to break this bond. So bond dissociation enthalpy will decreases down the group. So we can say the formation of H plus increases down the group. So if the bonds are weak, if we are easily break this bond, the formation of H plus, that release of H plus will be more. So we can say the acidity will be more when we are coming down the group. So the acidity increases down the group. So we can write the order of acidity, that is H2O less than H2S less than H2SC less than H2TE less than H2PO. So H2O and H2S, which is more acidic? H2S is more acidic since the acidity increases down the group. So that is the first point about acidity. Then next one is the thermal stability, which is thermally stable H2O or H2S. So the answer is H2O is thermally more stable than H2S. So with the same reasons, we can easily answer this question, that is when we are coming down the group, the bond length increases, bond strength decreases, bond dissociation enthalpy decreases. So the decomposition process, that means when we are heating the compound, the decomposition process will be easy when we are coming down the group. That means the bond will be weaker, so it is very easy to decompose. So the decomposition process will be very easy when we are coming down the group. So the thermal stability or the bond stability on heating will decreases down the group. So if we are heating the compound, the decomposition process increases down the group. So we can say the thermal stability decreases down the group. So the order of thermal stability will be like this. So H2O will be thermally more stable in all these hydrides. So the question is H2O or H2S. Here H2O will be more stable than H2S. So thermal stability will be more in the case of H2O. Now let us consider another question, that is which is having more reducing property. So all these hydrides are having a reducing property except water. So H2O is one hydride of group 16, but H2O is not having the reducing property. H2 is not having the reducing property, but all the other hydrides will show reducing property. So H2O will not show the reducing property, but the reducing property, the order of reducing property is that is actually increases down the group. So the reducing property increases down the group. So that is the point. So the reducing property increases down the group. So reducing property means if the compound is a reducing agent, that will undergo oxidation. So if the hydride is a reducing agent, it will undergo oxidation. That means reducing property increases means oxidation property. The compound which undergo oxidation, that property will also increase. So the compound will undergo oxidation increases, or the ability of oxidation that will be increases down the group. That is because the electronegativity difference. So the electronegativity decreases down the group. So the reducing property increases down the group. That is because the electronegativity decreases down the group. That means the tendency to accept electrons, that is decreases down the group. The tendency to release electrons, that is increasing down the group. That is why the reducing property increases down the group. So when we are comparing H2S and H2TE, H2TE will be more reducing. So we can write the order of reducing property, that is H2O will not showing any reducing property. So it is H2S greater than H2SC greater than H2TE greater than H2P. So considering H2S and H2TE, H2TE will be having more reducing property than H2S. So the reducing property increases down the group because the electronegativity decreases down the group. That is the reason. So this is about the reactivity with the hydrogen. So the reactivity with oxygen, that is the fourth chemical property, reactivity with oxygen. So it forms oxides. So oxides of the type EO2 or EO3. So dioxide or trioxide will be formed in this case. So dioxide or trioxide will be formed if it reacts with the oxygen. So EO2 or EO3. So E can be sulfur, selenium, tellurium or polonium. So in the case of oxygen, we know it will form O3. So O3 is ozone. You know O3 is ozone. So SO2, SO3, SCO2. So these are examples of oxides. Dioxides are there. Trioxide is there. So SO2, SO3, O3. So in these cases, these oxides are gases. SCO2 is a solid. So why SCO2 is a solid? Because when size increases. So SC. So when coming down the group, the size increases. So SC is having more size than the other elements. So when size increases, we can say the van der Waals force will be more. Van der Waals force of attraction is more. So that is why it exists as a solid. Then another property is reducing property of dioxides decreases down the group. So if you are comparing SO2 and TeO2, SO2 is having more reducing property. So SO2 is having more reducing property. SO2 is having more reducing property than TeO2. So in this case, oxygen is having -2 oxidation state and this will be having +4 oxidation state. So in both the cases, there will be +4 oxidation state. But when we are coming down the group, the stability of +4 oxidation state increases down the group. So the stability of +4 oxidation state increases down the group. So +4 oxidation state increases down the group. That means the oxidation property. So that oxidation property increases down the group. So +4 oxidation state increases down the group means oxidation property increases down the group. So the reducing property decreases down the group. So SO2 will be more reducing than TeO2. Then another point is non-metal oxides are acidic in nature. So in these cases, that means SO2, SO3, etc. If it is a trioxide, or dioxide, if it is dioxide or trioxide, anyway, the metal oxides, non-metal oxides, not metal oxides, non-metal oxides are acidic in nature. Non-metal oxides are acidic in nature. So SO2, SO3, SCO2, SCO3, etc. Whether it is a trioxide or dioxide, the non-metal oxides are acidic in nature. So this is about the reactivity with oxygen.